So in this video, I want to go through how to make um, plot transient fronts using this model, and I will explain what that means. So if you go into to look at an SV like this, so this was from the previous transient example where we had boundary conditions on these two surfaces. So this method where we plot transient fronts is only implemented for applying a boundary condition on this surface here, on the X back front, not any other face. So you will have to do that for this method to work. So only the X back surface. So we set that by adding a convective coefficient on X back equal to 100 for this example, and then ambient humidity on the X back surface equal to 1. And now I have to redo the transient simulation. So I invoke this method, lin transsolver. And then this method is the one that will plot the transient front, which is essentially is a graph that graphs the front for the different time steps. So we run the script, and now I pause the video until the computations are done. Okay, so now the computations are done, and we have got this plot that popped up, which was generated by this method, plotTransientFront. And what we see now is in X direction. So this is X equal to 0. So this would be the X back surface, and this is the X front surface. And then we see the for each time step, the average concentration of either chloride or moisture throughout this this SVE. So what the model does is that it takes the average like a slice at each X value and average that slice. So now it looks very uniform and smooth, and that's because we have very few aggregates. So if you have SVs with higher amounts of aggregates than we have in this example, these lines will be somewhat irregular in shape because we average over aggregate also. So there is obviously no, or the model assumes no concentration in the aggregates. So it takes an average for each slice in X direction, and then plots them for each time step. And then we see here that we have the initial value, which we set to be 0. And then we have the ambient value, which was set to 1. And so we have the initial value here, and then we see how that increases towards 1, which is here on this X back surface. So this is how this method works.